Hello, welcome back to the channel. In this video, I will share with you another example on how I use Agentic AI to improve the user experience and the perceived value of the analytics product that we are developing in our company, LogiGreen. So my name is Samir, I'm supply chain data scientist and founder of the startup LogiGreen. Over the past few years, in my blog and this YouTube channel, I have shared multiple case studies on how you can build advanced analytics products to help companies become more sustainable without impacting their profitability. And today I will focus the attention on a specific concept called green inventory management. And if I give you a bit of storytelling, I was a bit proud about when I learned about this concept, because few days after I was able to build a simulation model that would help companies to know how they can reduce their CO2 emissions without impacting that much their processes. The problem was that it was difficult for me to sell this concept to decision makers, supply chain directors, logistic managers. And I was a bit disappointed about that, especially that we have spent a lot of time in building this simulation tool. Today, I will show you how I used an MCP server to help some prospects and customers try this solution with their own data and the impact it had on their understanding and perceived value of this specific concept. So at the beginning of the video, I will quickly introduce you the concept of green inventory management and the simulation that we did. And then I will show you in an actual example how I used an MCP server connected to Claude desktop to basically let my prospect play with the data, play with the tool, and get himself convinced about this concept and signing a project with us. And then later, I will show you in details how I implemented this MCP server that is connected to a fast API microservice, like the other example I shared in this video. So if you are interested in learning how you can use Agentic AI to help companies become more sustainable, just follow me. So what is green inventory management? I will try briefly to explain you the concept and the results that I shared in the case study that I published 2 years ago. You can find the link in the description. Basically, the idea is to optimize the way that you are replenishing your store, to optimize your distribution chain and reduce the environmental impact of warehousing and transportation operations. So let's imagine that we are working for a small retail company that has a central warehouse delivering multiple stores. Every time stores need a specific product, they send an order using the ERP to the warehouse management system. This order is prepared in the warehouse and delivered to the store. For most of the time, these orders are triggered by inventory management rules. And if you don't know about it, I have a tutorial in the channel where we are building a simulation model to test multiple inventory management rules. So you have continuous review and periodic review. Here, we are talking about more periodic review, which means that the store system checks the inventory level every R days. So it can be, for instance, 7 days. And if the inventory level is below a certain threshold, you are ordering a specific quantity. So here, for instance, like a graphic representation of an inventory management rule. So here you have the demand. As you can see, it's pretty unstable. Here you have the inventory in hand, so the number of items that you have in the store for this specific reference. As you can see, this inventory on hand is moving due to the demand. Every 25 days, I think here, you are reordering. So every time you reorder, after 1 or 2 days, I think here's 2 days, the inventory on hand is updated, so you receive the product. And the idea is to be as close as possible to a specific target, which is here in blue. The idea of this exercise is to find the best parameters for these inventory management rules. I will not enter into detail, but it will depend mainly on the standard deviation of the demand, so basically the variability, the lead time between the order creation and the delivery, and some additional parameters like the safety stock. These inventory management rules will impact the efficiency of your distribution chain. So for instance, we are talking about carton usage. Let's imagine that you are replenishing in a very high frequency. That means the quantity per replenishment is very low. For instance, for this reference, where you have 20 units per box, That means for most of the time you are probably ordering less than 20 units, which means that the operator needs to open the box, take the units, put these units in a specific box with multiple other units. So that adds in the consumption of carton. While if you are ordering less frequently, probably you will order more full boxes. I have implemented this calculation inside the simulation model. So based on the different inventory management rule, you can calculate the number of additional boxes you have. And with a coefficient, you can calculate the weight of carton that is consumed. Same for transportation. Let's imagine that you are delivering frequently. That means you probably use smaller trucks that are not 100% full, which means that the emissions per kilogram delivered to the stores could be higher. So this has an impact, and this is directly linked to your inventory management rule. So the idea in the case study that you can find in the description was to take actual data from a retailer based in Asia Pacific and test for 90 days multiple scenarios of inventory management rule. So we have changed the parameters, and here it's mainly the review period, which means how frequently you are delivering the stores. And for each scenario, we calculate the percentage of mixed cartons, that is directly linked to the usage of carton, and the number of delivery trips and the truck filling rate that are directly linked to the CO2 emissions. And the results look like this. So for instance, here we have taken the review period from 2 days to 10 days. And what you could see is that first, until I think 7 days, what you could see is that the percentage of partial trucks, so trucks that are not full, is decreasing. And this is directly linked to the CO2 emissions. Then what you can see is like a strange phenomenon where the CO2 emissions are increasing, but I explained that in the case study. Same here for the usage of cartons. So here what we do, we look like at the percentage of full cartons. So where you have full cartons, you don't need to add additional carton material. And what you could see is that this percentage is decreasing even after 10 days, 10 review days. And this is directly linked to the material used in weight in kilograms. I was so convinced about the concept that I even deployed a specific module in our LogiGreen Apps, which is basically, I would say, like a web application that is publicly available. You can find a link in the description, that we are using to showcase the different analytics solutions that we can provide to companies. So you have, if you go on sustainability, you have a specific module called Green Inventory Management. And based on the different assumptions that I have shared in the case study, you can measure day by day. For instance, here I think is the percentage of mixed carton, full cartons. You have the visibility by store in the percentage of mixed carton. And what you can see here that C2 is really bad student. Here you have the picking order profile. So this number of lines per day that is directly linked to the warehouse productivity. I didn't talk about that, but green inventory management also improves the productivity of your operators in the warehouse. And here you calculate the emissions per store, the usage of wrapping film. I didn't talk about that too, but this is another environmental indicator. And in the store operations, the number of trucks that you need to manage and the number of pallets you need to unload. So basically, what happened is that when I was sharing this case study and this web application, for most of the time, decision makers were telling me, it's too complex, we cannot adapt that to our operations, it's too theoretical, even if I used actual data. So with now that I know a bit about MCP servers, I wanted to experiment what would be the interaction if now, instead of giving them the access to the LogiGreen apps, I give them access to a Claude desktop instance where they can directly interrogate Claude to ask specific questions on the green inventory management module with data that is directly coming from their operations. And this is the experiment I did, and I will show you that in the next section. So here we are in the Claude AI user interface. Imagine that for this project, I was working with a logistic director. He was involving in his team the one inventory manager, one warehouse operation manager, one transportation manager, and the lady in charge of sustainability. And the idea here was to make them use the tool together to test the different scenarios in order to reach a common objective, which is reducing the environmental impact and the cost of these operations. So obviously, I cannot share with you the exchange that they had because it would disclose confidential data. But what I did is I have replicated on my own instance the different questions they had. And the first one is they asked me, please tell me how to use the tool. And since inside the MCP server, I have implemented some prompts to explain to Claude how the tool was using, I was just asking them to ask directly Claude instead of asking me. And here, so this is what I did. The tool is sharing these core capabilities. As I told you, we are testing multiple scenarios based on a periodic review policy, which is what we call RS. R is the review period, so the number of days between two orders that you are sending from the stores. And the S is, if you remember well, the blue line, like the target that you want to reach. And the idea is that every time that every R days, you are checking the delta between your inventory in hand and this target, and you are ordering this delta. The idea is that this S level is calculated to compensate the demand between two orders, so R days. So for instance, if we are talking about 7 days, and plus the demand variability and the lead time. So here, Claude is explaining what you can achieve with the tool. So you can calculate CO2 emissions, carton usage, and plastic consumption. So I didn't talk about plastic, but basically plastic is linked to the number of pallets that you have to build. And you have a fixed amount of plastic that you need for the wrapping. The less delivery you have, the higher the efficiency of plastic consumed per boxes or units delivered is high. The tool is providing some information about the environmental footprint per store, because what we can imagine is that different stores may have different inventory management rules. And here the idea is to find the optimal review period, but also you can test some other parameters like the lead time, the operation, and which is part of the operational performance, so your order frequency, the mix of full and the percentage of mixed carton, as I told you, the transportation metrics, and the warehouse productivity. So here, the warehouse productivity, I didn't talk that much about that, but it's also a topic, and it's highly linked with the number of pieces or units or boxes per lines that you have. So why do we have these 4 people? Because you need a trade-off. And then here it is proposing a practical case study. So what I did is I told them, just do the first scenario, the baseline that is proposed by Claude. And for that, I have used Agentic models with default values, and I will show you that later with these default values. So here, this is a baseline, basically where we assume that they are delivering their stores in a very high frequency, which is the case for them. So what happens? So here you have a bit of a sort process from Claude, and then is launching one of the tools that you have in the MCP server that is called LogiGreen Inventory. And here is only putting one parameter, R equals 2. For the rest, all the other values, what you will see is that we have default values, and I will show you that later. And then it retrieves, thanks to the Fast API microservice, some results. And these results include the number of orders that you have per 30 days, the number of pieces per order, all the different KPIs that I showed you in the user interface, like in the LogiGreen app. Is providing some insights, which is good. But the problem is, and probably here I should adjust the prompt, is you have a bit of hallucination. Because for instance, here when is saying the frequency is high versus what? This is the baseline. You are not supposed to give some assessment. Moderate emissions, also, this is something that I don't like, because you are not supposed to provide, I would say, assessments based on a unique scenario. Anyhow, then this is what they told him like, how do you know that these orders are small? Where is just the baseline? And they ask for an approach to understand the impact of delivery frequency. It's exactly what I did in the case study. I gave them some hints on how to do that. And it proposed an approach. And let's not forget here, I didn't provide any, I would say, instruction on how to provide this kind of assessments. I just told Claude how the tools are working. And here is proposing multiple scenarios with different delivery frequency, which metrics to look at, and what would be the analysis framework. Then it runs these different scenarios, so with different review periods. And what you can see is that it's retrieving the results for all of these scenarios. And here is providing a very nice table with all the different parameters. I didn't even have this table in my case study because I was showing, and what you could see that in the case study that I published, I was showing metric by metric. Here, Claude made the effort of providing a kind of a complete table where you have an overview of all the metrics, so it's better than me. And what you could see is that, yes, the optimal scenario for most of the time is R equals 7. Then it's providing some findings. I will share that. I will share the complete discussion with you in the comment section, in the description. Sorry, so you will be able to review that. I will not enter in the details. Then next step, and this is where it's good to have the transportation team, the warehousing team. Here they are asking the impact of the delivery frequency, but also the lead time. And the lead time can be due to systems, but also warehouse operations or transportation. And here is reflecting on what we can do. And he decided to launch 22 scenarios. So where I think is changing the value of the review period, the value of the lead time. First, in terms of emission, so the CO2 emissions are mainly driven by the review period. The lead time is not impacting that much. The stock out, so the service level is impacted by the lead time, because when you have a review period that is too small for the lead time, that means that you are probably facing higher risk of stockouts. And then some metrics in terms of CO2 emissions. What you could see is that whatever the impact of the lead time, you have the same trend, which means that when the review period is increasing, you have a reduction of the CO2 emissions. And then it's providing a kind of an optimal scenario. I think the optimal scenario, probably with maximum sustainability, is with the highest review period and the lead time that is short. Why? Because you are minimizing the number of trips, and also with a short lead time, you are minimizing the quantity delivered, because you need to deliver less to compensate less demand, like a shorter demand. And you even have an executive summary for the supply chain director. So this is an example of a type of interactions. Here, this is a question that I added on my site. For this kind of projects, you have technical issues, operational issues, and then management issues. And here, the management issues is you have a warehousing team that may have different needs from the transportation team. These needs can be also contrary. And you have the sustainability team that is where the objective is to make people work together for the same target of reducing the environmental footprint, while they are already challenged with other KPIs like the cost. So I asked them, based on the parameter that you could see in the tool, what kind of framework you would have to make them work together. And I was quite satisfied by the framework provided. It identified well which parameters are impacting each manager. The only thing probably here that I would have changed is the lead time. The lead time is also impacted by the warehouse team, not only the transportation, but for the rest, it's quite good. And it's even proposing a collaborative workflow. So it's playing also the role of a consultant. And you will see also in this discussion is also providing an implementation playbook. So I won't enter into detail, but it's crazy. I mean, the amount of details that is provided. So then I started to follow this framework. I did the initial scenario where I told you I was not happy that much about the assessment. And then what is interesting, what I wanted to share with you, sorry, I asked for the phase 2. So the phase 2, it tested multiple scenarios, like 10 scenarios. And what is great here is that based on the results of the different scenarios, he named the scenarios with business names. This is something that I haven't done when I was doing the case study, where you have the baseline, the conservative scenario, the balanced scenario, the aggressive scenario, and the consensus. And the consensus is exactly the scenario that I've shared in the case study. But I didn't have this macro vision of putting all the different parameters in the same output and playing with a kind of a matrix to find what is the optimal scenario. And here's even sharing what is the impact for the different teams. That's part of the implementation, you know, and also getting a consensus, the agreement of all the different teams, because maybe some teams would be impacting negatively, but it would be good for the overall distribution chain. And even providing a scoring for each team based on the different parameters that are impacted. So definitely the added value is here. It's doing a better job than I was doing. And I would say this job is a job of results processing, summarization, and also marketing, how you sell that to different teams for the implementation. So I will not enter that much into the details. I wanted just to share with you this experiment that we did. In case that you have analytics products that you are deploying for companies and you have issues in selling them because maybe you are too technical or they are too complex, don't hesitate to do this, the same thing that I did. Connect that to an MCP server. So I will show you now quickly how I did that. It's very easy. So here we are in the setup of the MCP server. Unlike the previous ones that I have shared in the other videos, here I didn't spend the time to have a very complex setup. The idea was just to iterate with what we had and see, based on that, maybe add some tools. So in terms of tools, we only have 2 tools. The first one is just to launch the analysis. So that will call the fast API microservice that will run the simulation and then provide all the results. And here, it's an additional tool to help Claude to run multiple scenarios. And I added a prompt to basically explain the concept, the context. And here in the context, what I share is roughly like what you can find in the case study, but also with the operational point of view. So that way, all the knowledge about the fact, when, for instance, he proposed a framework to work with the different teams, is probably coming from here. So the idea is to make Claude a kind of not supply chain expert, but at least expert in the specific exercise of green inventory management simulation. In the actual context, I added some also additional details that are linked to our customer operations. And then you have this main tool that is used to launch the analysis. So it explains, it just explains the fact that you are sending a post request and what are the different input parameters. These input parameters are coming from this Agentic model. And here, in terms of default value, what I did is I used the default value, the baseline of the customer. So that way, when you ask run the baseline, Claude will know that it just have to keep the default parameters. Then if I come back here, it also provides a visibility of the output, the replenishment KPIs, the inventory KPIs, the material usage. Here, I didn't see the need of going detail by detail on the JSON that is received to explain to Claude what is done. And then I provide some guidance on how Claude should interpret this model. And to be very frank, I generated that with Claude Code. I gave Claude all the context, so the the full case study, also visibility on the code for the fast API microservice, and it generated that. And I tested edge cases, and so far I'm quite satisfied by the output. The only thing that I should experiment, that I should do, is to improve the prompting to avoid hallucination. So don't provide any, I would say, assessment when you are only doing the baseline. I mean, if you do the baseline, you don't know if the CO2 emissions is high versus what. For the rest, and what you will see also in the conversation that I share in the description, sometimes it's also like doing way beyond the scope of study. So it's providing guidance on how to implement new processes. This is not something that I expect from the tool. So this is something that you can ask in the prompt. Anyhow, I hope you are convinced that MCP server can improve the user experience, but more importantly, the perceived value, and help you to evangelize an audience or potential customers that are probably not interested in complex case studies with the support of Claude that would help your users onboard in a specific analytics product. If you have any question, feel free to let a comment in the comment section, and don't hesitate to have a look at the supply chain analytics playlist. I have other examples of MCP servers implementation, and some of them you can have the full implementation code shared in my GitHub. And see you for the next tutorial.